And we're back online. Welcome back. We have Prasad Yalamanchi, CEO of Lead Semantics here. Um, Prasad is running a company called Lead Semantics, and they specialize in AI solutions for language and knowledge processing. They are the originators of TextDistill, an advanced AI product that leverages state of the art large language models and NLP, natural language processing, and semantic technologies to create knowledge graphs from unstructured data. Prasad, it's always a pleasure talking, chatting, presenting, etc., collaborating with you. We're going to share your screen and I'm going to give you full range.
Thank you so much, Joaquin. You've been kind in the way you've introduced me. Thank you very much. Uh, Without wasting any time, it appears we have a pretty short time. I will straight get into the topic I'm here to speak today. The topic is explainable AI in sustainability and ESG practice. Um, in order to get to this subject, I will skip this slide. We have to first understand what sustainability and ESG practice in terms of the data handling, data processing, and what you do with the data, and things like that that are involved with this domain. That's the first part of the agenda, and then uh, as part of the topic itself, what is this explainable AI got to do with this ESG practice? How is it even relevant? And then we'll try and show a demo of the particular way this explainable AI can be brought into solving the problems that we expect to encounter in a ESG practice. And then we summarize, and then hopefully we'll have some time for Q&A. With that, I'll straight get into what is the sustainability and ESG data practice. What is the data and its role in this domain? You start off with, the amount of data is large, given that the nature of the deliverables that you plan for in this domain uh, are relating to a lot of data, a lot of variety of data, and a lot of high volume data that kind of is available on a day to day, every day, and throughout the year, and that type of thing. Things like complying with the regulations, and regulations are massive and onerous at that. Uh, Identifying with all that, businesses would have to look for opportunities and risk given what they're having to do with this ESG and sustainability related programs, and whatever the efforts that they are into, and the public relations and the communications and on and on. I mean, so much of it is revolving around unstructured data, which is highly voluminous, and as the name goes, you can directly have machines get at this unstructured data without actually mediating in some form. And the things that you would want to do with this data is that you're able to collect it, given the volume is so high. You want to understand it automatically if it helps, if the technology is up to snuff to be able to get you there, be able to aggregate it, be able to calculate, given the domain itself has a lot of numerical readings and things like that that you would have to extract from the data itself, and then tabulate and and report and so on. So it's a pretty tedious uh, work that needs to be done, and so you typically expect some level of support from automation. And clearly, this day and age, you would want to kind of see if generative AI is able to help you with these automated automation expectations. But one thing is that generative AI is highly capable and it has the potential to solve this problem, except that it has certain critical shortcomings that need to be one way or another addressed. The known shortcomings, even to date, are still these confabulations, so to speak, or hallucinations, as most folks know it. And the other thing is that these generative AI solutions are lack domain specificity to the extent that you would want for your purpose at hand. And in all of that, it also lacks explainability. The answers that it produces, whatever the results that it produces, they fall short in terms of explaining to the end user. So, given these shortcomings, if there is a way to fix these things, of course, generative AI would really help in automating this tedious, heavy work that is expected to be accomplished you know, to reach the goals with the sustainability programs. So it begs the question: what exactly is this explainability? Given that that is the big, hurdle to cross. Uh, so I'll just take a brief detour in explaining, possibly a little bit abstract, but not necessarily so, but it is
Pras-
important nonetheless.
Prasad, sorry, quick interjection. Do you want to hit on the slideshow present so you get
Uh,
full screen?
okay,
Yeah. Um,
I have the presenter's view. Is
yes,
that
sir. That one. Yep. You're all good.
okay? So thank you for that. Is that now visible?
Yes, sir. Full screen.
Okay. So, as I was saying, the explainability it sounds a little bit abstract, like the way you would talk about it and so on. Uh, but I mean, it is very practical in what to expect from such an exercise. So, briefly, something is explainable if you are able to, as a human, get an insight that is understandable. I'm not going to get into explaining what understandability and in all of that. That gets into a lot more hairy and recursive discussions there. But some insight that you are able to understand, relate to it, feel satisfied that it is explaining what it is that you are trying to make sense of. You know, and there is clearly, given all the machine learning expertise that is around and such, there is this one approach that is being pursued in many ways. It's like trying to understand the inner working of an AI model, because we are trying to, after all, trying to see how generative AI, which is AI models, LLMs, and so on, the large language models, how can you apply them to, help you in automation and such, right? And so, in order to get to the explainability of what this generative AI will produce, there is an inner working. If it is understood, then maybe it will make sense, and it automatically the answers are explainable and satisfying and so on. But all of that is fairly esoteric in itself, and it is for machine learning experts. But the context here is that the outputs of no matter what the automation is, and given it is generative AI in this case, the end users themselves would have to have one way or another get that satisfaction delivered to them, and through the explainability is what we are looking for. So in other words, the end user is an important participant. You cannot stop with just the ML expert itself. Again, you will get into a big last mile gap between the ML experts understanding of the inner working of large language models and the end users, and so there is that gap. So the end goal itself is that the end user gets the explainability, in a satisfactory way to themselves, and then so they get on with the results that they see, and feel good that and have the confidence to make decisions based on that and whatnot, right? So in that sense, the answers and the approach should engender the trust in users in the results that these LLMs or the generative AI produces. And explainability in that in that way should give you what is this result, how did this result come about, or the answer come about, why is this the answer, and are the answers conforming to my expectation. These are the fundamental questions of explainability. So, and these are the questions that have been around for the last year or so. Once the giddiness with generative AI has fallen a little, a little low, and then people kind of started focusing on how to improve uh, the, the quality of the outputs and things like that, so that the confidence in the results, improves in the end users. And the techniques that have taken on a lot of traction are these retrieval augmented generation techniques called RAGs. They improve upon the weaknesses of this generative AI by default. Like, for example, the accuracy is improved, and in that sense, the confabulations, the hallucinations are lower with the RAG technique. They are much more domain specific, but still the weaknesses persist. There are again, some aspects of weaknesses like the coverage in all of the answers that you might expect may not be met, and they still confabulate, and then the precision itself is not to the expectation. So overall, the explanatory ability is still, there is something left on the table to be desired. And enter knowledge graph RAG solutions. This is knowledge graph powering the retrieval and generation, retrieval augmented generation that improves on all the aspects of the weaknesses that we still highlighted with the typical RAG approach. It is comprehensive. Uh, the confabulations, the hallucinations are minimal. Again, there is a lot of room to tighten to what extent that you can aim for minimizing these things. Is it, whatever the percentage that you set a goal for your business process. And these are, uh, you know, they can cover all kinds of domains, whichever the domain that you are interested in. And in the net of it is that they provide better explainability. And how do knowledge graphs deliver that? And so that's what this slide gets a little bit into it. It's the so-called the underlying ontologies of how you design these knowledge graphs. Ontology is that schema of different concepts and how they interrelate. Uh, the concepts are of the concepts of the domain, the subject matter at hand. And so these ontologies help all these processes no matter what. And in this case, generative AI would be the one to extract these entities from these unstructured data. And so these ontologies help constrain the extractions to the common understanding of the domain. And in that sense, they have a high degree and high potential to meet the user expectations. And the verification of the results that are produced by this process are through the backlinks to the source data, source unstructured data. And so, and then in addition to that, you also have, given that it's a graph, have the relations to other entities that are there, which kind of give you that substantiated view of the place of this particular concept or an entity that is a focus for you. And given all the relationships are correct, it kind of consolidates your understanding, reinforces that this is correct or not, and so on. So net of it is that it delivers that satisfying result that this is the reasonably explained. So, and there are tools in action already. I mean, this is not a theory at this point. And we have one tool called Text Distill, which uses generative AI and knowledge graphs together to deliver the structured output from unstructured input. And the structured output is itself a semantic knowledge graph, which is readily available to be queried, and you can do business intelligence with and report using this structure and so on. And this is particularly useful, as I said in my first slide. The amount of data and the nature of complex data, the kind of variables that you have to deal with in this ESG and sustainability space, the chemicals, the measurements, and the nature of abstract descriptions of how these all things come together to deliver some business goal. These are all narrative in nature in some cases, and they have these images that go along with it, tables at that, so on and on. This is like a pretty serious data that needs to be handled, and this infrastructure, this kind of a pipeline stuff, is apt to deliver on the goals of such an analysis. Without too much time, what I would spend on this slide, I would like to take you all through a little demo that literally talks about this pipeline that uses some unstructured data as input and produces the output, and then the explainability being evident in the tool itself, to the end user. So if I may, I will switch my tab to the tab where I'm running the product. Text Distill is name of the product, and we can log into this. It's running on a link, textdistill.ai. I'm logging into it, and so when you log into the tool, it puts you into the screen, with several options here. There is a corpus and open search, and these are the two views of the product. I'll first go into the corpus view, and these are all the various corpuses, that have been processed through text distill. I will go into ESG and show some of the input documents that were processed. So these are the, each one is a document. So for example, in this case, we are dealing with text. It's just running text with all kinds of mentions of climate related variables and measurements and so on. It's just a running narrative text. And so you can, these are all the documents. We'll come back to it and see how these can produce these knowledge graphs. These are processed, and so knowledge out of these documents have been extracted and put into a knowledge graph. I'll go into the search side of stuff because these are already processed, and I will go into the search here. And so we have the corpus of about 150 odd documents that are all related to ESG and sustainability and such. What I will do is in the interest of time, I'm not going to type in, I will just copy and paste some questions here. So here we are asking which company is working on which green variables, climate variables, what greenhouse gases and etc. And so this goes against the corpus, of processed documents, and all these answers are coming back. And you can look into any one of these answer, and you can verify where it may be coming from, and say industry is investing in wind, solar, conservation technology, and green operations. And so sure enough, it must be coming from some piece of text here. So we can, and if you notice, this is actually using RAG plus, which is the basic RAG. Something like this, any of these questions, you can use the graph RAG side of it. And so it gives little more, for simple questions, there may not be too much difference, but for complicated questions, as I will hope to show, it gives you more ways to really look at how the data and the results are put together. So I clicked on this text block, which is kind of right next to the document that was producing the answer. It highlights the text from where this Chevron is concentrating on waste oil. So here we'll see Chevron is one way or another is involved in here. And the same thing you can also verify through the graph view. This is what the graph side of the graph rag part of the solution gives you. Graphically also, you can actually explore and see, where all it's coming from. And if I click on it, it highlights the same thing. So again, as I said, the simpler questions, it's not so much that you can get out of it, but it is still nonetheless, this is what is happening. It tells you how this green variable, climate variable, waste oil is related to the company that is working with, so you can just follow these edges and all that. This particular subgraph is actually pulled out of the bigger knowledge graph that is pulling all the knowledge from this document. So there is a bigger knowledge graph in the database that is of the knowledge that is extracted, and of that knowledge graph, this particular subgraph is answering the question that you have asked, and so you're able to come back to this. Let me ask a little more complicated question and see the difference between these two, graph rag and rag. As I said, graph rag is much more comprehensive. Let's start with rag plus. And of course, it produces answers. And as you can see, all these answers are coming from a single document. And by the same token, it may not be answering all the propositions of the question here. So here, the propositions of the question, the so-called different segments of the question. So the company has invested in another company, and that company is working on which green variable and what are the measures of the green variable, the climate variable, and any dates associated with it. As you can see, these are all answers. So it says, for example, something, or even we can take this new Carlyle venture to fund green. So the answer itself doesn't really have everything that is being asked for in the question. We can check something longer here. A green transition business it has built. So these are all answers, but none, they are not necessarily kind of answers that have all the elements that you are looking for in the question. Green transition. So this is an answer. It may answer some part of it. Maybe there is overlapping and things like that. This is representative of the vector database underneath that is kind of putting it together. That's the nature of the typical RAG. I don't want to waste too much time given we are running out of time. I'll quickly run the graph RAG, and then graph RAG does produce much comprehensive answers, and so it does have uh, much more clearer. For example, I can click on one of these answers here, and you can see that this answer produces, and this answer is answering all the elements of the question. So here, EIB is investing, so much money in Enel Group Power, and Enel Group Power is concentrating on wind energy, the green variable, and the capacity of the wind energy is 2 gigabytes, and all that. So some parts of it. So these are all the different text blocks from which these elements have been pulled out from these documents, and you can check to see, click on different things and see is that where some of the answers are coming from. Like here, 600 million facility will support the growth of Enel Group. So it's this is being answered here, and we can check and see the rest of it where all it may be coming from. So here, it's talking about EIB providing Enel with the sustainability. So if you follow the trace of these things, you will see that these answers are indeed coming from this text. And same thing here for the second part of it. So you can quickly see that these two documents together are producing all the different propositions that you're looking for. And the same thing, when it is a complicated query, this is where the graph really shines. It pulls up all these different elements, and then it might take a little bit of a time to find its ideal locations. Let me pull, and you can actually see how these things are all interconnected by following the edges. Here is a business arrangement that is between a European Investment Bank and Enel Group. And Enel Group is working with the green variable called wind, and the wind has all these things. And then you can click on this attached text blocks to see where that block is in the text right next to it. Let me clear this, and so you can see that this is the text block that is producing the corresponding edges and all that. And you can click on this, and somewhere in here, yeah, this is very barely you're able to see, but that is what is happening here. So without spending too much time here, I'll quickly go to the corpus and show you how you can, for example, the full knowledge graphs is what I said, right? When the documents are processed, you can get the full knowledge of it. Now here we are seeing the full knowledge in the graph view. And you can bring up the node labels and edge labels, and this is each document, for example, has a different color, and these common nodes among these documents are in red color. So you are able to see some entities that are common between the documents, and you are able to follow them with these edge labels and things like that. So each one of these are all result of the predictions that are coming out of these machine learning models that are applied on this data. And by the way, and this need not be just text only. I mean, this can be video, audio, image as well. uh, it takes a bit more processing for audio and video and things like that, but they nonetheless come and join these graphs. uh, so these are the knowledge graphs here. And whenever you ask the question in the search interface, it is pulling relevant subsections, and that's why it's able to pick up, multiple underlying documents that are answering the question that we asked. And just to give you a flavor of, something more complicated, for example, in these things, a little more complicated, I guess. Tables is one thing that we have routinely found in ESG as being a pretty important and significant aspect. And for example, let's see what we can pull up some document here. So the document itself is on the left hand side loaded. As you can see, this is the table, and you do want to interpret. These are multiple tables here actually, and it's the same thing. It extracted all the knowledge, and it's in here. This particular pound sign here, or hash sign, is a row in a table, and I can reset this a little more, and let's see, bring up node labels, and maybe click on some node here. So this is highlighting the table here, and in this table we can click on, for example, a row. Let's see, any row here. Let's say is this connected to that? Yeah, this is row 11, and I'll just pull it up here. Oops, clear selection, but I'll bring up the edge labels on this. So you can follow these edge labels, and they will correspond to these things that we are seeing here, and you can, and these column headers. These column headers are, let's see, this is methods of measurement. Methods of measurement is here, and that alone is all the stuff that is 11, and this thing is here. So it is extracting all the cells and columns and column names, and as you can see, it's fairly involved in extracting all of those things, but you can tractably follow all these things. So now the important thing is that now this running document that has tables and all these complicated layouts and such is now broken down into a very atomic structure that is accessible to your querying languages, your search, and so you can do many more things with it. And by the same extension, if there are measurements like numbers and things like that, they can be extracted. They are extracted, just that that's another layer. And then you can compute those things, aggregate those things. You can do all kinds of business intelligence, which is extremely relevant for ESG reporting. Things like air filters and air quality monitoring and things like that has a lot of these tables, 5 different types of gases, and all these chemical formulas and things like that to be extracted out of their narrative form in which they are generally communicated. It's a pretty helpful thing, and you can validate it by looking at these graphs, as I said, that delivers the explainability that you would want in order to be satisfied with it. Yeah, with that, I will stop and see if there are any questions.
Prasad, it's always a pleasure to hear you present on this area where you're so knowledgeable and you've been implementing products into practice. Um, yeah, have you encountered any particular use cases that you'd like to highlight in the implementation of this technology? Like, where does it add value? Who would benefit from these kinds of solutions?
But we are talking in terms of sustainability and ESG domain.
Hmm.
Clearly, text distill and this type of knowledge graph coupled with generative AI is a tool set that you will probably hear from all corners of these industry vendors going forward. Just recently, Gartner itself has announced, or kind of one way or other communicated, that in 2025 all generative AI projects, 50% of them or more will be also working with knowledge graphs. And a tool like text distill and such is pretty relevant to that landscape. And particularly in sustainability, to your question, the use case, for example, where we have seen is um, there are companies in the US, for example, and I'm pretty sure in the European zone as well. Um, they have these air quality permits that they would have to apply, manufacturing facilities particularly, from the government. And these air quality monitoring, they come with all kinds of stipulations and expectations from the permits that they get from the government. And they are all about these greenhouse gases that contribute and are kind of pollute the air. And so these measurements have to be um, you know calculated, first collected from these equipment, calculated, tabulated, all of that. And so there is a lot of paperwork that floats around, all these documents and things like that. And people are finding it so troublesome to keep up with it, and tools like this are extremely valuable in getting them to their end goal. That's
Excellent.
one area I can think of. Yeah.
No, excellent. Thank you very much, Prasad, for this presentation. We're going to be taking a short break, and then we're going to get into the second panel discussion of the day, making supply chains transparent. So we hope to see you there, and we'll see you in about 20 minutes. Thank you, Prasad.
Thank you.